So chapter 12, introducing probability. Chapter 13 is another chapter of probability. So you see how important probability is. I suggest you try to get the slides for the chapters because it's going to connect to the next chapters. If you don't, we might have a hard time. Right? But again, I record my lecture, so. All right. Say, if I roll a 6-sided dice, what are the possible outcomes I can get? The dice is 6-sided. 1, 2, 3, 4, 5, 6. So what are the possible I can get? What is the possible outcomes I can get? 1 to 6, right? 1 to 6. Before you roll dice, do you know which one will occur? No, right? No. What is the probability that the outcome will be a 4? 1 out of 6. And why? Does it mean you roll the dice 6 times? One of the times gotta be 6? No, right? It means this is long-term rather than short-term, right? So say if you flip the die 1,000 times, 2,000 times, 10,000 times, as your number of flipping increases, the probability that you're gonna get a 4 is approach to 1/6, right? So that's what that means by there's 1 out of 6 chance you're gonna get a 4. When we talk about these, we meant long-term outcome instead of short-term outcome. I'm gonna use RStudio to simulate something. Share screen here. With my RStudio. I want to simulate coin flipping. So back in the day when we don't have, R and all that, we asked students to come up here and flip the coin for us. But now we have R, you don't have to flip the coin. So coin, the function coin is going to be in vector. How many outcomes when I flip the coin? 2, either head or tail, right? So head or tail. Let me dip capital T. Because H and T's are the letter, not number. They call string. You're supposed to put the quotation mark around them. If a vector is a number, you don't need quotation mark. Now the result. It's an empty shell. It's an empty shell, so the result is null. It's nothing. But if I run that, nothing. I don't need it. How do I get rid of this? How do I get rid of it? All right. Now I'm gonna do a for loop. So for I, or you can say J if you want. For so I in 1, I'm gonna flip the coin, say 10 times. Right, flip the coin 10 times. And then the result. You know what? I'm gonna write. Let me write my my code in the script. Let me write here in the script. Say 4. I in 1 out of 10. So I'm flipping the coins from 1 color 10 means 1 to 10. 10 times. See what happened? So the result of I, result LT of I is the sampling of the coin 10 times. And size 1, size 1 mean I have 1 coin. It's supposed to have like 2 coin, 3 coin. Replacement, do you guys remember replace? Replacement without replacement? Replace, I'm gonna put true. T-R-U-E, true. And then my table result. Spit out the result in table form, that's all. So let me run all that. Coin sign, 1 replace true. Something wrong, coin. Result is null. For I and 1, result. Did I do something wrong? Result. Sample coin. Nothing wrong. Sample, yeah, sample, you're right. Yeah, there's a function sample. All right, so it's lucky that you have 5 out of 5. Let's run it again. 3 heads, 7 tails. Let's run it again. 6 heads, 4 tails. What if I change to 100 times? So I flip my coin 100 times. 56 to 44. Let's run it again. See another 100 times. Say another student flipping it. 55, 45. What if I run it to 1,000 times? What's your number get close to? It's 50-50, right? It's close to 50-50. So if you flip the coin 2 times, 4 times, maybe you have bow head or bow tail, right? But as you increase the number of times of flipping, the result got approach to 50-50. So that's what I meant by a long-term probability. Right? There are a few ways to pick a probability. The first way is personal or subjective probability. So the notation for probability of an event is denote capital P, mean probability, and then parenthesis A is an event. It could be the event of flipping a coin, event of getting a space in your stack of cards, stuff like that. Right? So P of A is degree to which a given individual believes that the event A will happen. An example of this will be, say, if you watch a game with your friend, you guys watch a game? Did say you watching with your friend, or you see your dad watching a game with his buddies, and then your dad will turn over his friend and ask, what is the probability the Lion gonna win the cup this year? 20%, right? I would say 0, but what he say 20%. So that is subjective probability, right? It's based on personal guess. For this class, we don't go into that kind of probability. Why? Because it's based on personal educated guess aspect. So the probability is personal educated guess at best. It's very subjective. You're a Lion fan, you might be offended, but truth hurt. The other one is long-term relative frequency. Now, the probability of event A, denote P of A, is a proportion of times event A occurs if the random experiment is repeated many, many times. Think stocks. Let's stock. Say, how do people predict stocks? You know how people have day trade stock. How do they predict stocks to know what stock to buy? Well, they're based on the data they had before, right? They're based on the data they had before. So, for example, you have a portfolio when you invest your retirement account, say IRA, Roth IRA. If you invest it right over time, your portfolio should be increasing, right? And I'm talking about long term. I'm not talking about short term, right? Stock always go up and down. There's dips, there dips, and then there's up. But over a long time, talk about 10 years, 20 years, 30 years, the trend is increasing. So that's meant by the proportion of time event A occurs if the random experiment repeated many times. The moral of the story is get your retirement in early. You guys have the time. Right? So for this example, think stock. For this class, we're gonna focus on the baskets model. The baskets model. What is a baskets model? Probability of A is the proportion of marble in the baskets that have an event A on them. For example, say I have 10 marbles in my basket. 3 of them are blue, 7 of them are white. If I would randomly select a marble, what is the probability I'm going to select a blue marble? What is the probability I'm going to select a blue marble? 3 out of 10, right? 3 out of 10. Doesn't mean if you randomly pick a marble 10 times, then the 3 times you're gonna get a blue? No, right? Doesn't mean like that. For example, if you were to go to a doctor office and the doctor said you have 70% chance of getting this disease, right? It doesn't mean you have 70% disease inside you, right? But rather what, compared to similar situation with people who have similar condition and symptoms like yours, overall 70% of those people have the disease, right? So that's what it means by long-term probability. So in this case, if you would have randomly pick a model in that basket many times, repeated many times, the probability you're gonna pick a blue out of all 10 marbles approach to 3 over 10. So in short, the probability statement is not a statement about individual outcome. But it is a statement about what? A population outcome, a population or the baskets model, the basket. So about the basket, or in this case, population. So now you understand probability now. I know people say things all the time in everyday life, but they don't actually think too much about it. They don't actually relate it to the math behind it. A flush. Do you guys play poker? Okay, poker? No. I'm bad at it because I'm not good at making poker face. Yeah, I'll probably lose a lot. You read online that the probability of being dealt a flush mean all 5 cards at the same suit in a 5-card poker hand is 1 out of 508. Explain carefully what this means. In particular, explain why it does not mean that if you are dealt 508 5-card poker hands, one will be flush. So what does this mean? Take a moment and write out your thought. What does it mean to say one out of the card when you deal 508 5 poker hands, you get a flush? What does it mean in terms of long-term probability? Missions. It means in the long run of a large number of in a large number of five card poker hands, the fraction in which you will be dealt at a flush is 1 out of 500, right? You know, long run. So you would write like this. So you would write 1 out of 508 means that in a long run of a large, how large? Quite large numbers of five card poker hand. The fraction or the probability in which you get a flush is, I would say, approach to 1/508. Maybe we will write a little bit more. It doesn't mean 1/508 such five card poker hand will yield all right, this one. Winning the ACC tournament, the annual Atlantic Coast Conference men's basketball tournament, has temporarily taken Joe's mind off of the Cleveland Indians. He said to himself that, I think that Louisville or Louisville, depending where you live, has probability of 0.05 of winning North Carolina probability is twice. I'm gonna say Louisville, okay, because I'm not from Kentucky. I think Kentucky, Louisville, just two. Is that what they call syllables? Right? I'm just gonna say Louisville because I'm not from Kentucky. The Duke probability is 4 times Louisville. All right. What are Joe's personal probability for North Carolina and Duke? So probability that the North Carolina, we know in NC, wins. What do you think that it's gonna be? What is the probability that North Carolina is winning according to Joe? That's Louisville. One, right? One. Because Louisville, the probability of Louisville winning is 5%, and then North Carolina double that, so 10%, right? So 0.1. What is the probability that Duke gonna win? Duke wins 0.2, right? So 0.05 times 4 is 0.2. What is Joe's personal probability that one of the 15 teams other than Louisville, North Carolina, and Duke will win the tournament? Probability of others win. What is the maximum percentage for probability? 1, right? 1. So the leftover probability for others win will be 1 minus those 3 teams, right? Louisville is 0.05, North Carolina is 0.1, Duke is 0.2, 0.65. So far, so good. So that's subjective probability, right? But we're using it to calculate the rule of the probability. Sample space. Sample space is just a fancy way of saying possible outcomes of an event. So sample space denote S, capital S, not little s, capital S, of a random phenomenon or random event is the set of all possible outcomes. So for example, if I go back to the flipping coin, what is the sample space for me rolling a 6-sided dice? 6, right? So those are my sample space right there. Those are my sample space. It's just the fancy way of saying all possible outcome. An event is an outcome or a set of outcomes of a random phenomenon. An event is a subset of sample space. Let me go back to that example. So I say what the event that I'm gonna get a 4. That is a subset of the sample space, right? Because in sample space there's other 5 outcomes, right? So 4 will be the subset of the event that you get in the 4. It would be the subset of all the possible outcomes, just capital S. Right? So distinguish between what is sample space and what is event. Right? Event, the smallest subset of possible outcome. Probability model is a mathematical description of random phenomena consisting of 2 parts: a sample space S and a way of assigning probability to event. So sample space, visually, we denote in a rectangle. And then if I want to denote the probability of A happening, I'm going to draw a little ball. So that little ball is the probability of A. It could be 0.2, 0.1, doesn't matter, right? As long as it's between 0 and 1. So that's one way to write a probability model. Of course, it's not mathematical description. Mathematical description would be what? Say P of A occurs, right? Occurs. This is called the Venn diagram. The Venn diagram. When you take discrete math, you run into this a lot. Probability and set theory. Venn diagram is not a formal mathematical proof when you want to show something. It's good for visualization, but for math class, they don't like this as a formal proof. You're gonna write it out. But for this class, I'm okay with Venn diagram, and of course, you have to give me the conclusion too. All right, let's take a look at some example about sample space. Choose a student at random from a large statistic class. Describe a sample space as for each of the following. Does the student have a pet or not? So sample space denote capital S equal, because you're listing out possible outcomes in element. So I allow you to use curly bracket. What is my possible outcomes here? What are my sample space? What is my sample space? I'm talking about this one, number one. Two, right? Either you have a pet or you don't, right? That's only two options. So let me see how I write it. Pet or don't have a pet. Or pet or no pet. I'm gonna write like that. What is the student height in meters? So what are the possible outcomes? Of course, it's vary from student to student, right? As long you give me something reasonable, I would start at 0, even though when you was born, you're longer than 0 meter, right? So maybe I'll start with 0.5. It depends. You can start at 0.1 if you want. It's not wrong. Um, let me start at 0.2 just in case. And then 0.3, right? 0.35, 4. It's continuous random variable. So 0.35 all the way to, all right, 2 meters really long, really tall. 2.5, I think it's a maximum. Let's take a look. Who is the tallest person in the world? See how tall he is. Let's say 2022. Last one I heard was a Chinaman. Sultan Kofun. Sounds like German. All right. 272 centimeter, which is equivalent to 2.7 meter. That's very tall. Roughly 8 feet. Average American will be what? For women, will be 5.4, right? For men will be, I would say, 5.9. 8 feet. Really tall. So yeah, I stop at 2.5, which is makes sense. Oh, it is. I wonder his shoe size. I think they had to customize his shoes and his clothes, obviously. Gemini. Yeah. 40. Usually tall, these unusually tall people, they don't live long. The, the proportionally is not ideal, right? If they would have tripped over and broke the ankle, it'd be a lot of, it'd be a severe things, right, as opposed to a regular person. Right. Am I sharing? Yes, I'm sharing. All right, next one. What are the last three digits of a student's cell phone number? You can start out with what? Yeah, 000, and then 001, 011, any combination, right? All the way to 999. So those are possible outcomes. What is student birth month? Yeah, January, February, all the way to December. That's sample space. So you understand sample space now? Like all the possible outcomes. Here are some property of probability. First, the probability that event A occur is within 0 and 1. Minimum is 0 and maximum is 1. So when I ask you to calculate a probability of some event, if you have a negative number or greater than 1, something wrong. The sample space is, in probability model, the probability of the sample space is 1. Does that make sense? I go back here, the probability of me getting a 1 is 1/6, getting a 2 is another 1/6. 1/6 add 1/6 adds 1/6 6 times is 1, right? 6/6 is just 1. The probability of a sample space is always equal 1. Two events A and B are disjoint. Sometimes they call that mutually exclusive. Mutually exclusive. Maybe that word better for you to imagine. I use disjoint just because it's shorter, but I think mutually exclusive would be the nice way to describe two probabilities that have no intersection. So two events A and B are disjoint if they have no outcomes in common. So they never occur together. For example, it's either raining or not raining. It can't be both. Either you flip your flipping will be head or tail. Can't be both. Right? Either you get a job or you don't get a job. Right? So things cannot happen at the same time. If I were to denote this in Venn diagram, let me draw it again. So that rectangle right there, that's my sample space. The probability of that rectangle will be 1. Right? Remember what I said about the ball denote probability of an event. So say the ball, red ball will be the probability of event A occur, and then the blue ball will be the probability of event B occur. You see no intersection, right? No intersection. If I would have do some addition, the probability of A or B, that's addition rule. When you hear or, mean addition. So or imply addition and imply multiplication. But right now, or addition, if I want to know the probability of A or B, addition, we add them together, right? It's going to be equal to P of A plus P of B. A lot of times you see me write like this. Notation for or is union. So I would write P of A, P of A union B. It's the same thing as P of A or B. So or mean union. Union means add them together. Now later I'm going to introduce you the general additional rule. So this is one, the basic one. This is a basic one where two events are disjoint. What happened if they looking like that? Don't write this down. What happened if they like that? Right? Then we have a different additional rule, which later. We'll talk about that later. Complement rule. probability of an event A does not occur. And we denote that as P of A complement, like that, or P of A bar. Let me visualize that for you. What does that mean? Again, I have my sample space. I have my probability of A here, that's law. So the probability, everything but A, the probability of everything but A will be what? Everything outside the ball, right? Everything outside the ball. Everything outside the ball. Sorry, I touched the ball, but you're not supposed to. So the yellow part will be P of A complement. Everything but A. P of not A. And to find the probability of A complement, you take 1, subtract the probability of A, and you get the yellow part. So far, so good. Simple rules. It'll get a little bit hairier, but I hope you get these rules first. Has anyone ever visit Canada? Where do you go? Me too. I did, yeah, long time ago, like 13 years ago. Anybody else? Well, you go to Niagara Falls, that's Canada, so it counts, right? It counts. Canada has 2 official languages, English and French. I think people in North Canada speak more French, and people are closer to us. In the South, more English-wise. Choose a Canadian at random and ask, what is your mother tongue? Mother tongue means that's how they was raised, right? They can speak both though. A lot of them just speak both, but there's mother tongue. So here is the probability of mother tongue is English. It's roughly 57%. Probability of mother tongue is French is roughly 21%, and others. So what is the probability? Now, when I say mother tongue, that's disjoint probability, right? You only have one mother tongue, unless you're. I'm just assuming here you only have one mother tongue, unless your dad French and your mom German or something like that. Maybe you speak German too. But let's just say mother tongue is English or French, not both. So they disjoint. What is the probability that Canadian mother tongue is either English or French? So what kind of probability I'm talking about? Is it additional or additional, right? Either or. So P of English union French if you want, or you can say or French. And they disjoint, so we'll add, yeah, just add them together, right? So 0.78. What is the probability to replace question mark in the distribution? So here P of others, right? Remember complement, right? Complement, right? So 1 minus English and the French, right? So 1 minus 0.8, which is, yeah, 0.22. Thank you. What is the probability that Canadians' mother tongue is not English? How would I do? What kind of probability I'm talking about? Complement, right? Complement. So P of English complement. We note like that. Everything but English. So be what? Yeah, 1 minus 0.57. 0.43. Or you can add the French and the others together. So let's do 1 minus this complement. All right, I hope you guys get the compliment and the additional rule, the destroy event. Are they destroy or not? This is something you see on your next quiz. Yeah, I give you a bunch of scenarios and you tell me whether they destroy or they're not destroyed. A person is selected at random. A is the event the person selected is less than age 18, and B is the event the person selected is age 18 or over. If I was you, I would draw the event diagram. So there are two events here, A and B. Yeah, there are only two events in this scenario. So event A is someone less than 18, and event B will be 18 or over. And you know what, less than 18, I think it look like that, right? Greater than 18. Are they disjoint? Are the two events are separate? Yes, right. Yes, I know that you see 18 on both boxes, but the thing is that the left one is less than 18, right? 17 and 11 month and 20, 30 days, 39 days, right? And then the right box would be 18 and over. So yes, they disjoin. There's no overlapping. I'll let you think about number 2 for a second. Draw it out. Draw it out and help. What do you think? A person is selected at random. A is the event the person selected earned more than 100,000 K per year. B is the event the person selected earns more than 250K per year. Destroy or not destroy? Not destroy, right? Because, well, why not destroy? Yeah, that's a subset of 250, right? Yeah, that's a subset. So if you draw it out, for me, I'm not good with English because for one thing, it's my second language. So when I took my first math class in America, I don't understand what the professor said, but as long as you write it out, it's clear. Because math notation is universal. It's the same. So yeah, English is not my strong suit. Good for you if you can write well. It's helped you a long way. Um, so so that's my sample space. And then somebody make more than $100,000 will be this ball, 100K. And then somebody make more than 250K with that ball, right? 250K. So there you go. So 100,000 is a subset of 250. So no, it's not destroyed. Oh, the number 3 is a little bit twisty. Let's see. A pair of dice is tossed. A is the event one of the dice is a 3. B is the event the sum of the two dice is 3. What do you think? John, right? Right. So event A is, let's say event A is a 3, but event B is what? It's something plus something equal 3, right? So they disjoint. Right? So they either 0 and 3 or 1 and 2. Right? So they disjoint. Hopefully you'll be able to distinguish disjoint or not disjoint on your quiz. Give me a second.